To Mr. We can start.
Okay.
12:05, yeah. Then start,
Okay.
let us say. Yeah.
Yes, yes. Now, we were here, we have saved our file that we have updated. Okay, you can see in my video if you missed. And then after, we are going to use this file uh, to, to do another work. How we can analyze little bit more. Let's check first. Okay. The first step, we have to import the file. Okay, now this is the okay. Now we have to import it and show whether the data is correctly imported or not. Okay, this is the thing first. Now, okay, perfectly. Okay, perfect. It's a missing and here is NaN that we did. Okay. Now the second things we have to compare the columns with the target variable because our target is the earlier we saw that our target is which variable level. Okay. Now here we are not going to find out whether it's the what kind of category of this attack. Okay, we are going to find out whether the attack is performed or not, 0 or 1. Okay. That's why the level is the target, and now we are going to compare a little bit so that we can understand about the data set. Okay, this time we are going to understand the data set first, as we discussed. Okay, now we have to compare words. Okay, and if you see the comparison between protocol. Uh, Okay, after the analysis, we will discuss a lot. Okay, that's why we have to understand how we can describe. And then the comparison one is the protocol with label, and you can see that the label is 0, 1, and how many numbers from ICMP. It's a little bit balanced. Okay, okay. This is not balanced. It's somehow three times this, and you can also visualize this using the bar chart. Okay, you can use this bar chart technical report. Now it's your responsibility that how better and how attractive you can make your technical report. And as I told you, this link you are going to share with your any interviewer or in future, so that it will reflect that yes, learn something and you have some good result. And here you can see that I told you TCP has this has one has a loss. Okay, okay, this is the things, and then we have to think about another comparison that is this is a service and label. We are going to do with service and label. Let's check what kind of what kind of data they have. Remember, we are only looking on the data. Then what kind of data we have collected? Either you downloaded data or for your own data that you generate cybersecurity tools. Okay. Okay. Then you can also visualize with heat map. Okay. And here the basic thing you know about heat map plot, that the color, if it's a color more darker in the red, okay, then it's positive correlated, and it's a dark blue, then it's or it's no, it's starting from 0. Okay, okay. We will discuss in another part that how we can see the negative and positive correlation, but here it's going to positive. That's why it's a 0, means no, it's very less comparison, and it's go up, up, up. Then you can find that the missing value is the most here, the level. Okay, level 1 has the, okay. Now after looking this, we know a little bit about data set, okay? And these things you have to write for each column, okay? And that's why I will show. And remember, this data science or data descriptive kind of job is very uh, irritative or repetitive. You have to do, okay? So that we can understand. And this is very important part. Then after we saw little about data pre-processing, and this thing I discussed, okay, discuss a lot in my previous class, okay, the last day that I have taken a session. Okay, you can watch my video if you don't know the thing. First, if you want to go to data pre-processing, first you know that what kind of data you have, okay, so that we can do something with data. Okay, now you know that here missing is there, it's okay, but this place it's trouble. Okay, it has lots of missing data. It's okay, we will okay, and we have to, I think we replaced that time with median. Did you remember? But it's not showing here. Am I right? We have it, solve it. In our previous session, I have put the data with median. Let's check what's the problem there. Where we did, yeah, this is missing. Here we replace it. Did you remember? But it's not showing. It means we have to replace it again because we must have the NaN with some data. Okay. Now we saw that some problem is there. That's why let's go for this. Okay, DF this, okay, and then we are going to fill with median. Okay, this time median. And now if we check again, okay, these things I missed. Now it's filled. Okay, now it's filled because the missing value must not be there. Otherwise, it will give you. Okay. Now what will be the next? We have to is there any more thing we can do in data pre-processing? Yes. Suppose we want to, in many cases, I found that a student told that, sir, I have a very big data set, I am not able to run in my system or computer or something. Okay, lots of problems are there. Then in this case, you can also reduce your data set. Suppose here I reduce only top 1 lakh data. Okay, but you may go for another things. It's not only for this. Okay, if you want to shuffle or something, a lot of options are there. But I'm only showing that we are taking from top 1 lakh data and we are going to work on that. Okay, or not, then we can. Uh, if you don't, then you have to only delete it, only make a copy so that if any kind of change will happen, then okay, let me comment it so that you can understand, because it's a general problem. Students face that the code is not running due to huge data set. In this case, you reduce, you take 10,000, 5,000, 50,000, what you want to take, you can take here. You may put shuffle or something. Okay. Now here I copy entire data set so that we can see what is the effect. Okay. It may take a little bit long time, but it's okay. And then we have to do some kind of encoding because we have two categorical variable. Okay, name are there, and you know that in machine learning we have to put some numerical value. Okay, we cannot insert the text. Okay, and if you have any kind of text data, then you have to encode it. Okay, and here we are going to do some one hot encoding. Okay, you can check it over on internet and write these things. What is in one hot encoding? Okay, this is simple thing you can understand easily. Now we are going to convert the text uh, into numerical form. Okay. Now it's level count. Okay, level count is also there because we are going to check. Okay, the level count is there. Okay. Okay, lots of things are there we can do. But first check what happened with one by one, we have to understand. First, we are going to check this, then what happened with this if you go with encoding. Okay, then what it will do, it will, if you check the information about this, then you can find that the new columns has been created. You can see. Okay, and this is due to one hot encoding. Okay, it is going to be encode. You can check the details of this. I have. Okay, now after using this, after converting numerical, now we can go for developing a machine learning model. Okay, now uh, in some cases, okay, you may face problem with libraries. Okay, the version of libraries, and as I mentioned earlier, that if you go for Colab, then it will reduce the error. But if you go on your system, suppose you want to run this on your system, okay, with Anaconda or Visual Studio Code, then you may face some problem with this gradient boost, okay, and this is due to the library problem. Okay, you have to upgrade in your system. Okay, and you can find the solution over internet. But still, if you have any kind of doubt or problem, then you can ask me. And help you in this regard. Okay, let's check in Colab. Is this working or it has still? And see, some symbols are there. You remember in ChatGPT, you can find some symbols or you can add your own. Okay, it should look nicer. And that's why I told you you have to mention some good image or something so that your collab will be attractive. Okay, that's why I put these things here so that you can understand. Okay, now if you, and these things I explained in my last class, all libraries are there, it's useful. And these are the models. Okay, these models we are going to use. If you want to add more model, and these are the classifier. Remember, we have selected classifier. Why? Because our label has binary category. Okay, and categorical kind of variable is there, that is binary. Yes or no, or 0 or 1. Okay, you can add more if you want to add, but these are the sufficient. Okay, famous machine learning algorithm. If you want to learn, then let's check, is there any error? Okay. This logistic regression passed, it has very less accuracy. Okay, and remember, we perform on only 1 lakh. No, okay. We perform on entire 2 lakhs, 2 lakh plus rows. Okay, then it may take some little bit time. Okay. Now you can see here the accuracy. Okay, this is the training accuracy, training, testing, validation. We have studied in the previous class. Okay, now here you can see the logistic regression is very bad. Okay, and here random forest is a little bit okay. Gradient Gaussian, it's also fine. Okay, here you can find that. Okay, okay. Okay, then the next one, let me add the code because we already studied last class. After that, after getting these results, what we have to do? We have to observe it. We have to find something, some extra things that we can do. Okay, because and then you have to observe and write your observation, that what kind of observation you perform here. Okay, uh, let's go for the PPT that we have discussed in the last. Okay, there we if I first this gradient, this the ADA boost was the winner in that demonstration, that PDF we saw. Okay, you can see here the ADA boost was the winner. Let's go for this. Okay, and check about ADA boost what is going on. Okay, and okay, we have to check the overfitting, whether it's overfitting or not. And now support vector is running. Okay, but let me save the code, because these things I already provided in my PPT. But here in Colab, you also get no need to type. Okay, you have to find, you have to analyze your result using this kind of code. After running this, you can see it's yet running. Okay, after running this, we will run this code. But after overfitting, we have discussed one more things that you can do using a hypertuning test. Okay, the hyperparameter adjustment, you can also perform some operations. Okay, then how we can do this? For that, we discussed in the last session that we can use different kind of values for different kind of yeah. Okay, different kind of values. Did you remember? We have explained this thing and learning rate, different kind of learning rate, and now this grid search cross validation will find out which one is the best. Okay, for giving the result, because we are find out ADA boost was the okay. It's still taking a lot of time. Okay, let it take. Okay, then we can find this thing that which parameter is the best. Okay, and what is the actual accuracy, if it's if the accuracy happen with overfitting. Okay, then we have to sort out with this problem. Okay, and then we saw that in the PPT you may see that after that we saw that the importance of features means that if you run, if you train your model, then what is the impact of each features? Okay, which has the highest impact while training your model? Okay, so that you can focus on that important features. Okay, we can discuss about features and how we can know, how we can run these things. For that, we have a simple command that is provided, but here we are running, so that you will not claim that you are not getting. Okay, this is taking a lot of time. That's why I was taking 1 lakh. Okay, now you can understand why I was taking a few less rows due to this, because it will take a lots of time. Okay. Okay. Now you understand that why we are using feature important, because after training you have to understand that what kind of importance for each features. Okay, according to that you can decide or you can do something more. Okay. And then the second highest was there. Let's check in this code what is coming. Okay, then after we can you may change that which algorithm is the highest one, approx 100% accuracy. Then you go for this kind of test, that is overfitting, and then you can go for hyper parameter tuning, and then find out the future. And then the second winner, okay, the runner up model, you have to increase the accuracy. Okay, then how you can do? You have to first analyze this. Okay, analyze it was the prediction on test. We have to check the test data, what is the accuracy for test data, okay, and accordingly we will okay. Now test data, same thing we can do, but what is the difference? Here in test data you have to pass y test and no, here y x10 y10, and here you can pass x test, okay. Now in this way we can find out what is the accuracy of this, okay, and after that we will perform that some imbalance problem is there. We can see, okay, that our class 0 has a lots of values, okay, and lots of values are there. You can see here, I press the label. Where is the label? We saw the label somewhere here. See, okay, this is the imbalance. Class 0 is here, is the less, okay. No, we have to, okay. We took lots of, okay, here this one is the more, okay. Accordingly, but okay, accordingly you can do which one is the more, which one is the less. According to that, you have to check, okay. But I will provide some code so that you can do by yourself. Suppose the handle the class recall for class 0. According to the result, we will see. Okay, let's result will come, and then after we can discuss on that. But okay, and here one technique we have used, that is SMOTE. Okay, normally SMOTE will take care about this. Which one is imbalance, it has to care about that. Okay. It will be 0 or 1, don't worry, it will care. But how we can use, that is the things, okay, and that we have studied, but here we are going to see that how we can use it, okay. Here this is the SMOTE, you can import it, okay, using there, and then after you have to use here SMOTE.fit, so that it's going to resample and fill the all unbalanced thing. It will take care about that, okay. Okay, now this is thing, and how we can train test, you know these things very well. Now let's check the things, and let it come there. Then after we will see that is there actually going to fill or not, okay, level is going to balance or not. For that we will test it, that y trend resample. Can you see y trend? Where is the y trend resample? Y trend, okay, white, because we want to check this, okay, that is going to uh, balance or not. First we will check, you can check this one also, but if you check this value count, okay, then you can find that whether the imbalanced data that is here is going to balance or not. Let me check here, okay, we saw it 0 1, and let me check here. In this case it's 1 instead of 0. Accordingly you have to write your technical stuff, okay. Do not think that this is a thing that you have to type and run your code. You have to see your data set, you have to see your result, and accordingly you have to analyze and write, okay. Now here what happened with this code, now you can visualize that what will come. It's going to count uh, how many levels is there and what is the number of that, and it should be balanced. Why? Because we have used here SMOTE, okay. It's going to synthesize the data, it is going to feed it, and let me check is it completed or not. Still it's running. See the problem, if you have huge data set, and this is the problem, even we are on Colab, okay. Okay, Now, the first things we have know, and now the second is using using class C, using class weight. Okay, the two things we are going to do. First, we are going to balance using SMOTIV, and then we are going to balance with this class weight. Okay, remember we are doing three things one by one. First, we are only training our model. Okay, different kind of algorithms we have used, and then after we will select the top one, the highest, the genuine highest accurate model, and then after what we are doing to what we are going to do at the end, we are going to balance the data set, okay, using SMOTE, and second, the class weight. Okay, two ways we are going to weight. It means we have to check that is there any improvement or not. Okay, this is our goal. Okay, now let me check. Class weight in random forest. Okay, class weight using class weight. Now this will the things that I gave you. Okay, now we are going to check using this. Okay, and another important thing, that if you are going to use the algorithms that we have used here, 5, 6, 7 algorithms, then you have to write about each algorithm. Then what is the basic thing about this? In Python, what are the options are there? Okay, what is the meaning of this? Okay, these are important things you have to mention, so that you can use another option for a better for training purpose. Okay. Now still you can see the things that is going on and on. Okay. Then in this case, what we can do, we can, okay, wait for some time. Okay. Let me complete it, so that at the end you should find all stuff, all things that you have to do. Class weight random. Okay, now we are going to balance it. Then what is our purpose? See, someone of you asking about how we can compare, how what we have to show. This thing we have to show. Okay, after doing this thing, you have to compare that what is the impact on this kind of thing. Okay. Now, if you see, then if you remember, then the code is little bit same. Okay, this code I copied from your Colab 3, where we have checked that, okay, NumPy or that list list comprehension. Okay, it means you can use the code, but the purpose is to show your talent, your skill. Now we are going to check here. What we are going to check? This class balance using a SMOTE, and their class weight, and what is the difference, percentage difference between them. And we are interested to see this, that what kind of difference is there. Okay, because it's depend on data set. Each data set has different kind of value, and accordingly you have to write the stuff. Okay. Now, if you want to see in the bar chart, since the difference is very less, okay, that's why this is the better information. But if you want to see bar, then you know in the earlier we also saw how to draw the bar chart. Okay, here you can show that this is a SMOTE class, this is the waiting class, and then we have to show the bar chart. But bar chart is not effective here because the difference is very less. Can you see the difference? Okay. Okay, let's the result will come, then after we can decide that which one is the good, bar chart or the simple value. Okay. Not coming? Result? Not coming? Okay. Then you may stop it. Stop it. Let's stop it. Or you may interrupt. You may interrupt it. There is the interrupt. You can see interrupt the execution. Save. Okay, then we will restart the session. Don't worry. We will. Okay, yes. And this time we will take less data set. Now you realize that what's the problem with the mode. Okay. And we need our data from where? Because we are going to use this data updated, and this is the second session, and here we are going to use. But see, if I run this, then the problem will occur. Why? Anyone guess? Because we are using this PD, okay, and PD is not here. Am I right? PD is not here. That's why first we have to run this import. Okay. Yes. Now you can run this. Then the data will come. Okay. Now run this. Now data is okay, and now these things we have compare. Compare is okay. You can run again. It's because we are not doing anything here. But one thing we are going to do here, that is the filling the value. This is the important. Now you can see the information. Now it's perfect. And now here we are going to use this. Now this time so that we can see the other results that what we can do. Okay. Suppose 50% of data. Okay. DF encoded is not there because I did not run it. Okay. Check. DF. There is that. See, here we have used DF to collect this data. Okay. Now, okay, okay, and then after we have seen this one, okay, and now here we saw the information. Okay, but we have encoded. DF is okay, DF information is here, okay, now it's fine. Now here, why this error will come? Anyone see? See, the first is the error, sorry, I did not see the error, okay. Now see, this is another common mistake, okay, by the student, that unexpected ident means, see the gap, it should be here, am I right? But it is here. See, one space caused the problem, okay. Now you have to delete it. Now run again. Now check. Now see. Now it's okay. Okay. Now here again it's an imbalance because it's 8,000, it's only 1,000, but the data is a little bit less. Let's run this, but since we saw that, which one was the, okay, SBM was the time taking. Okay, let's comment it so that we can continue the session. Now start it and check. Now, these things, precision, recall, F1 score, support, these things we have discussed a lot. Okay. You have to. Okay. Now here. Okay. Till you may ask any question if you have any doubt, because what we are going to do, you can understand that first we develop our model. Okay. Different model. Then according to the result, we have going to analyze it first. Okay. Here the result is there. According to the result, we are going to observe. Okay. And what will be our next step? We will decide from here. And after discussing this, after deciding this, that okay, this is the model. we will again going to check, can we balance it and then some improvement will there. How we can balance? We are using two things, SMOTE and second is class balancing. Okay, both things you have to apply, and then we have to check that is there any improvement or not. Okay, because we try to improve our accuracy. Okay, our model's accuracy, and for that we will do a lots of things. The things at least that we have learned in the session, the theoretical session, the last and the in my previous day. Okay, now what happened here? You can see here AdaBoost is not top one. In the another kind of data set, I found 100% accurate. Okay, if it's 100%, then you can go for this observation. Okay, or you may run. Okay, you may run, check whether it's working or not. Okay, let's check. If you check, then what happened? It's checking. It's cross validating. Okay. Here is the pointer. Okay. Mainly we are using overfitting when we get that the very high accuracy like 100% or something. It means something is wrong, and then we will cross validate. And here you can get the result that that the average is okay 91.93. Okay, 91% is the average. Okay. Now in this way you can find that what is the actual, because this is the different folder, different fold, it will give different accuracy, and we will use the average of this. Okay, that will indicate the accuracy of our model. Do not try to write down the things that excited and you are not confident. Okay, suppose you got 100% accuracy and you are super excited, and write down that I have 100% accurate model. Then in interview they will ask you lots of questions. Okay. Uh, that's why first of all, before producing result, you have to make sure that is it with confidence or not. And then after we can use this hyperparameter to change. Okay. Different algorithms have different kind of things you have to check, and accordingly you have to tune the hyperparameter. If you tune it, then check what's happened on which parameter it has the highest accuracy. You may write that result also. Okay, but the average is the good one. Okay, you have to show the average one. Okay, okay, it's going to learn it. Okay, see the fit means it's going to learn. X train, Y train, we discussed a lot. Okay. And this is the training phase where the independent variables and the corresponding value is passing in this AdaBoost algorithm, and this algorithm is going to build a model, and then after we are going to test. Okay, here is the test is going to be passed. And then it's going to find the best parameter, and according to that again it's going to train. Okay, it's going to find the best parameter, and then after it's going to again train this model. Okay, it take too much time. Okay, let it be complete. Yeah, it's still in testing. Okay, and then after we will find that future importance. It means while training, which feature impacts more. Okay, so that we can conclude in our result that yes, these features are important for our algorithm, in our AI based algorithm. Okay. And after that we will go for forest. Okay, and there we will go for test data, that that whether the test data has higher accuracy than training accuracy or not. And after that we will try to improve the accuracy of this test data. Okay, is it possible or not, because the class, the level is imbalanced. Okay, that is 0 1, we have to balance it, and then after still it's going to fit. Okay. Okay, it's checking. Actually, it's checking. Okay. And now you can see that the best one is learning rate is 1, estimate 100, and the accuracy is 91. Okay, 91.96% accuracy. Okay. Okay, now we can find this from different kind of hyper tuning, hyperparameter to tune it. And then after we are going to check that what kind of impact of each feature value. Okay, and if you run it, then you can find that what is the error? Feature name is not there. Okay, feature name. Okay, Adabos feature name is not there. We will check where is the feature name. Okay, feature name we will check where is the feature name. I think we have to add it. Okay, let's check here. I also have some feature. Okay, feature will get you. Okay, we will add the feature importance. Okay, since I deleted something. Okay, now let's check for random first so that I will show you, and then after we will discuss on that whether it's doing some error or not. Okay, let it be complete first. Okay. Now here you can find these things. I think all of you remember what is confusion matrix, what is the value of this, and the accuracy is 94.3. Okay. Now what we are going to do here, okay, let's complete this random forest first. We are going to balance the imbalanced data level, okay, using SMOTE. And instead of level, it's going to balance all because we are going to fit, okay, it's going to balance this data set and this data set too. Okay. Now, if you try to run, then what happened here? Okay, now here SMOTE is giving 93.6. What was the accuracy previous? Last 90. See, that's why I told you if you want to do data pre-processing or any work, then it may not that always it's improved. Yeah. It may be less accuracy. Okay. Now, but check the next things that we can do. That class weight. Okay, class weight balance. Let's balance the class, and then after check what is the difference between accuracy. Okay. This has 93.66%. Let's check there. Is that okay? Now it came. This is 94. Okay, you can see here the above one 93 and this is 94. Okay, it means some improvement is there. Let's check. It's a 1% accuracy, exactly 1%. Okay, approximately 1%, and 1% you may not reflect by this. See, it look like same. Okay, but here this result is effective. You can say that minus 1% is improved. Now let's check the things that we want to check this future. Okay, Okay, for future importance, first let's check the how many features are there. First check, and then after we can think about name. Okay, these are the columns. Okay, these are the columns that we are going to feed here because the missing thing was future name. Okay, and features are these things. And if you provide features, then it will give you the importance of the things to predict that attack. Okay, that is the level 01. And you can see here that the destination port has a more impact. Okay, then source port, then prototype, UDP has more impact, then TCP has more impact, then HTTP depth is more, and then service, and others has very less impact. Okay. Now after looking these kind of information, you can upgrade the things. Okay, and you can see here the missing value, how we can compare the missing value. Okay, with two techniques, and then we saw the result that some improvement is there. It means something happened. Okay. Now, these things, I repeatedly told you, you have to think more. Okay. Do not depend on other AI kind of platform that they can generate the code and you can write in your technical report. No, you have to do one by one that we did. And then after you perform, you write the performance of the models. Okay. Now, up to this point, you understand the things, how to build our model, how to identify the important points in the trained model. Like Adabos, we saw that this is a overfitting, then how we can check. And then after in random forest, we saw that how we can check that imbalance problem. Okay, how we solve it as mote and class balance. Now the another term that we have studied last day, that was data transformation. Am I right? Now using data transformation, you can also increase your accuracy, your model's accuracy. Now, how we can perform? Again, we learn a lots of things that day. Okay, if you not remember, please go through my PPT and lecture video. You can find a lots of things there. Okay, now for demo purpose, we will going to see that how we can run the things. Okay, now what we have to do, we have to, okay, let's check what is the data because we are going to perform data transformation now. Okay, now let's check because this is also important step. Other ups, the step that we have discussed, you already saw. Okay, now it's another, and this is a point where you have to write a section in your training model section. In subsection you may write and write down what kind of data transformation you are going to use. Okay, lots of methods I discussed last day, but among them let's do one, that is data discretization. And among data discretization, you saw binning and the equal frequency. Okay, these things we have covered. Okay, now we will see how we can use here. Okay, how we can use. For that, first you understand what is the value for this. Okay, what kind of because we are going to transform our data. First you again see that what kind of information you have. Okay, then since if you apply anything, it should not co-produce any kind of error. It means data is encode, then info, you have this kind of information, but I intentionally put here xtrain.info. Okay, if you try to run this, then it will give you some kind of error. Okay, due to data mismatch. Okay, since this is a pandas data frame, that's why you use the operation of pandas data frame, and this is converted into list. If you go up and if you find, then it's performed into list. If you run this one, then you can see, since these are the common problem, that's why I want to highlight here. Okay, okay, that is the things that we did not check there. Okay, the above somewhere it's converted into list. Okay, when I was doing, then that time it was giving the error, but here we did not convert into list. That's why it's look like same data frame. And if you feel any kind of, if you face any kind of issue like this, then you go for conversion of data. Okay, I have some example, perhaps let me show that trend dot column. I think this is also a kind of okay, let me check, is this working or not? Okay, this time it's not converted to list. But if you perform some operation, okay, because I did lots of operation in my previous experiment, and I found that this is converted into list. Okay, and in that case, it was not. It was producing the error, and that's why I put these things to show you. But this is not. Producing error. If any kind of error is there, then you go for the previous one, previous data, that is in data frame format. If it's a list, then go for data frame. Then these functions will work. Okay. It means I want to say that if the data type is different, suppose list is there, and you try to find out the column of that, or you try to run dot info command or dot head command or any dot describe command, then it will not run. Okay, because the data type is different. You have to do the operations on the perfect data type. Okay, if you change, then the error will come. Now you saw that we know the column is there, everything we saw. Now what we can do, we have to separate the future value from target. The above one, you can use either the above one, or you can use this one also. Okay, because here I will try to do both thing in same way. Okay, the validation testing and the and the and the training. Okay, these things we are doing to same. How you can do? Here you can see that in our data set, label is the target variable. That's why first we are going to separate it. Okay, separate it and put it inside in the independent variable. And then in dependent variable, we have only label. Okay, now you have perfect X and Y. That is that the target is separate from the data set. Okay, and now these independent variables and these two X, Y is going to pass here. It's going to split it, but this time we are split in different way. Okay, that's why I put intentionally, I put the different code so that you can understand that if you go for another kind of code, you can perform the operations. Okay, here we are going to validate parallelly, and then after we are going to test it. Okay, how we can validate? Then we have to divide our data set into 70 is to 30. You can see here 0.3 means your test size is 0.3 means 30%. Then train size should be 70%. Okay. And if you apply this code, the line 1, then what happens? It's going to give this train validation X text corresponding target variable, Y train, then corresponding target variable. This is for validate. And then you have to divide into this X train that we have divided. Okay, to make a validation while running. Okay, in this case we are going to divide into 20 into 80 ratio, 80-20. Okay, because 0.2 is the test size, that's why it's going to be 80 size. Okay, it means training. See, the concept is we are dividing the training, and inside the training, okay, we are using the validation and training. It means testing is separate. Testing is 30% that we did here. Okay, testing is separate 30%, Now 70%, out of 70%, okay, we are going to separate 80% for training and then 20% for validation test. Okay, this is the division here, so that it's a little bit tricky, or you can say that confusing. That's why you have to understand this. Otherwise, you may stuck. If somewhere give you this code, or if you find some code like this, you may not understand that point of time. Okay, that's why it's nothing. It's only first divided into 70/30, and then the training 70% is going to be divided into 80 into 20. Okay, and that 80 into 20 is training and validation testing. While uh, learning our model, it will going to validate. Okay, and then we will go the same code that we have do the last. You can also do this thing little bit. Okay, and here I put some max depth 10. If you do this, okay, what is the impact? You can realize. If you remove, then what is the impact? Because in the previous code, we did not add. And that's why I told you, you have to go for this kind of classifier, okay, and check the different kind of parameters. That what kind of parameters is this, and what is the impact of that, okay, so that you can do in your code very confidently. And if you run this first test, what is the accuracy? Because we are focusing on the accuracy, and so that we can compare that what is the improve or deprove the thing. And remember, we are doing another things here, data transformation. Okay, a lots of things I am telling you, you have to do so that your document will be good. Okay, it means it should be uh, informative. Okay. Now here it's called x value is not defined. Why? Because did I run this? Check, I did not run this. Okay, that's why the error is coming. X value is not, but I put x value is here. But while discussing, I did not run it. Am I right? That's why first we have to run it. Now it's perfect. Now run it. And in general, if you face any problem in the code, then you have to restart your kernel. Okay, restart your session. Okay. And now here you can find 93.88 validation testing, and here the test accuracy is 93.61. And earlier you can see it was 94. Okay, it little bit this line of code that we did with test, and you remember the previously we did for train perhaps, or the less accuracy may be due to this, okay, because we have split into two parts. Okay, here you can see, and that may be the reason. Okay, and that's why it's another demonstration that if you use your algorithm in a different way, it may be happen that same data set will produce different kind of accuracy. Okay, but let's go on this, that the accuracy is this, and now we try to improve with our data transformation discretization method. Okay, how we can use discretization method? For that, first we know the columns. Okay, that on which column we are going to provide the operation. Again, if you select anything, you have to mention that why you are selecting this. Okay, why you are selecting this. You must show the justification that yes, that's why I am using it. Okay, suppose we see the column, and then we want to do we want to perform our data transformation on this port. Okay, we feel that okay, this is the this has all values or numerical kind of thing. We took it. Okay, but you have to give the justification. Okay, with different. Okay, now you can see that this the source address, destination, and HTTP depth. It's only one. Okay, can you see? It means, okay, let's check the extension version of this. That is the, we can also plot and then check what is the effect of this 1? Because we can see that this is only 1, 1, 1. Then is this the any use to do if all are 1? Let's check in the figure. Okay, let's plot it. In bar, yes, it's only 1. You can see. Okay. It means if you perform any kind of discretization, okay, either bits wise or frequency wise, then it will not impact. But what happened here? You can see here the impact may happen. Okay, because it's a little bit scattered a lot. Okay, it's not a kind of good distribution. Now here we can apply some discretization. Okay. Now let's choose this source port and destination port. Okay, remember we are doing only on this kind of only up to this. Okay, uh, yes, port. It means seven columns we have selected, and we have how many columns? We have 44 columns. Or if you generate the data from your tools that you are learning, it may have different columns. It may have more columns like 60, 70. Then you have to analyze on that, okay, and find out on which column you are going to perform the discretization or any kind of data transformation technique. Okay, see, this is only one that discretization, and especially for frequency by discretization. You have a lots of techniques that we have discussed. Go through the PPT, you can find, and you may apply any techniques and find out that whether the accuracy improve or not. Okay, let's try first this that we have discussed about discretization. Okay, now if you want to apply any kind of data transformation, then again you will give a lots of hints over internet. Like suppose I want to apply equal width discretizer. Okay, then you can go, you can find some code is also there, Jupyter Notebook code. Okay, that's why I told you. If you want to apply any kind of concepts, lots of codes will be available. Okay, now we are using here equal width discretizer. Okay, not frequency. Okay, let's check first width and then we can also check if we have time. Okay, now check what happened with width. Okay, let's run first. Okay, some problem is there. What is given? It's telling that no name feature. See, no name feature engine is came. No model. Okay. If you find this kind of error, then find on the internet that I told you. Okay. That this problem in okay, feature engine. Check what is the solution. Solution is installation of this feature. Am I right? You have to install this feature, and if you want exact code, then you know simple that pip install is the code. Okay, here you can see pip install. Okay, either you go for exact version or you may simply write pip install and then this feature engine. Okay, then it will install. Okay, it means you have to do something before that, otherwise it will not run. It means you have to go for, or you can go for this side. Let me open. Okay, you can open this. It's for you. Okay, you have to get help from there. And now check what is there, how they are using. Because they have running code, it means they did something. Now you can see they did equal discretizer. Okay. Now, okay. They did not install. They already install it. Okay. They already install and then after they run. That's why you cannot find. Okay. Then you know pip install and what you want to install, this feature engine. This this thing you want to install. Okay. And here in Jupyter Notebook, you can write this marks. Okay. Now it's successfully installed. Okay, like that you will work and now again run. See the error, solve. Okay, it's very efficient platform is there. Okay, now what we are doing, first we see that what kind of a boundary they make, because we discussed that equal beats and equal frequency, in equal beats the boundary will be fixed, but equal frequency the boundary will be changed. Okay, and I also gave some code in my PPT. Okay, dictionary is not there. It means you have to you have to import this dictionary, this DIC. Okay, it's okay. Let's check the things if you want. Do you want to install DIC? Then you have to find out that. Okay, where I was. Okay. Okay, if you want to check that what is this, then you may go for that name error and see the problem. Okay, 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 you can solve it. Now I show the things. Now let's go further. Okay, so that it's easy. Okay, do not think that this error is very big. You only search and you can find lots of solutions. Okay, now let's check that. Both, okay, both, because we did some, okay, we did not, okay, wait, we did not run this. Let me run, because these things I did not create it, okay. Let's check first. We have to write here something. Okay, here we are going to add, okay. Because we need this discretizer, okay, and since we already imported this, okay, and the bin is 10, you may reduce it, you may take 5 if you want, okay, then accordingly it will change. And this is the some explanation. You can see how we can transform it. Now you can check it, okay, that how many boundaries are there. You can see the different boundaries are there, and we have explained it. Okay, no need to waste time here. Now, since we know that what is the boundary, then we have to check the difference. Then what happened before and after? Okay, and how we can see train. This is that, and this is the equal bit discrete. Can you see? Both are different. This is for our actual data set that we are doing, and here we transform it. Okay, now it's a transform. Now let's check what is happened. Top 10, top 5 column, five rows we are going to check. Okay, now if you check, then see the difference. Difference is here you can see the port. Okay, now it's going to equal with discretizer. It's going to make into how many bins? You can see how many bins we have created. Where is the bins? Here we have created 5 bins. Okay, and you can see the 5 bins. The range is there, and accordingly the range. Okay, the value will be inserted. Okay, and that's why this is the bin number. Now you can understand what is this 340. These are the bin numbers. Okay, and for understanding, suppose this is 4, you can check fourth bin is here. This is okay. 1, first, 2, 4. Okay, and the range is uh, fourth. Since it's a start from 0. Okay, that's why 0, 1, 2, 0, 1, 2, 3, 4. This, okay. It means 5, 2, 3, 4, 7. Okay. 0.4 up to infinity. Okay. Then you can see here. Okay, you can see here. That's why these values are here. This value and this value. Okay. In bin 4. Okay. Now in this way, theoretically I explain. I think those who present in my class, they can understand. Okay. Now what happened with this? If you transform the data, then let's check in plot also. If you want to check, okay, that what's happened actually. Then in plot, I think I will not get that thing because it's discretized. Okay, now you can see the effect. Okay. Okay, these effects are there, but is really effect on the result? That is the thing. And see, the effect is not too good. If you analyze, you can see 0 is very high. Okay, because uh, you may consider, as we discussed, that this is the outer, this is the initial, and this is the out, and all lower values will be come inside the zero. Okay, and all here plus infinity, it means the upper value will come into 4. It means you can analyze that the upper value is very less, okay, and lower values is more. Okay, that's why this come inside this bin. Okay, okay. Now let's check the effect, because the final goal is to check the effect. Okay, what is the effect on this? Okay, now if you go for this, then again test. Check it, what is the effect of this? Now we are using this. Where is that? Is this we have changed, am I right? We have changed XML. See, can you see? We have changed here. Okay. Where is that value? We have transformed. Okay, train EWD. Am I right? Check where you are passing or not. At least you should understand. Okay. We are not passing. Can you see here? We are passing here X train. Am I right? Same value. Okay. This is not things. It means it's a mistake by everyone. Okay. Here you can see this is transformed. Am I right? This X train WD, this is transformed, and now you can put here. Okay. XW, EW, and this Y train, it will be, there is a transform. This is the Y train. Which value we are going to pass? See, this is the X train, and we did not discretize it. Okay, that's why it's okay. Okay. Now this is the make prediction for validation set. Okay, this is for validation X val. Then instead of X val, it should be. See, we have changed here. Okay, you have to check X EWD. It should be EWD. Am I right? And then accuracy. This is okay, and this is Y val. It's okay. The Y val is Y val will same. Okay, because no need of discretization. And now accuracy, this one, and classification report, Y val, okay, and this, okay. Now it's fine. I think everything is perfect. Make prediction on the test set. Okay. Y test under predict X test. Okay. Shall we X test? Shall we X test? Yes. See, this is very important. Okay, it's not important that you are using the algorithm. Important is, did you use the exact or correct data or not? Okay, let me check, is there mismatch? Okay. Now, what is the performance? Can you see? Performance has been degraded. Okay, it has been degraded. It means using this, you can increase or it may be decrease. Okay. Now the second things, you can use equal frequency. Okay. And for equal frequency, you may go like that. Okay. Try to use equal frequency discretization and check whether it's a improve or deprove. Okay. Okay. Now this is in this way you can do. Now let me explain something, because most of you are leaving it, okay, leaving the session. But the problem is the main things is coming here. Okay. Do not leave the session. Where is day 4? Okay. Now final, where we cover our agenda or not. Let's check. Okay. Now what you have to do, because now after that you have 2 days weekend, and then after class, and we will meet after 6 days. But what you have to do, that first I will share this PPT, link is there, you know already. Now here, handling missing value. We handle the missing value, okay, filling the mean, median or zero. Am I right? But you can do with different method also. How? Because now this is your method. The previous one was the others are the general method that you have to replace with zero or mean, median, mode, etc. But how you can do by yourself? See, this is a new concept. Any of you apply it, okay. If you apply successfully and get some result, okay, then it may be your own work, okay. Or if you want to publish it, at least one time please contact with me, because most of the students I taught to most of the students to do this, okay. But of course if you do by yourself it will be different, okay, and we will make it different. But do not try to do the same thing that I am telling you and you write and send in any conference or journal paper, okay. It may be you may find some plagiarism issue because it's already mentioned with most of the students, okay. That's why first of all you have to learn that how you can transform it, okay, and then after you apply, okay, apply and contact how we can modify it, okay. Now here the problem with our data set, the sample data set that was only six columns, okay. Here you can find 4 and 5, that is service and HTTP trans depth. These has some problem, okay. And the service is a kind of categorical variable that we know, and then this is the quantity variable that is one, mostly of one, okay. Now how we can fill it, how we can fill it, then for step one, this is absolutely new things, okay. You may try it, those who are interested to do something. Now how we can fill this unknown value, this missing value, the technique that we have discussed about filling zero or replacing with median, this is okay, okay. But here we will use something extra so that you can use in your report. What is the extra? First, what we are going to do, we are going to develop a machine learning model, okay, to fill this missing value. How we can do? How we can do? We can use step one, that use the model to fill service missing value. Why service? Because you can see, no, here it's we do service column as a target, okay. We are going to use service as a target. Why service as a target? See, you have to write, this is not a statement in the sky, you have to in the air, okay. You have to understand and you have to write the steps. But why we are going from service? Why not with HTTP? Because service at 303 null means we can find exact data set at least, okay, at least 303, okay, rows. Using that rows we can develop a machine learning model, and once you develop that model using the target, the service as a target, then you go for fill that missing values of service, and then after we will make this HTTP trans depth as a target, and then make a model to fill this, to predict it, okay. In this way you can fill, okay. If you have if you did not understand or you are in confusion, then let's explain it in another way, okay. And this way you have to mention in your document also. What is the different way? See, these things we have studied in the last section, okay. That how we can represent the data, okay. And here we explain that this is the x1 x2 to x5, these are the independent variables, and y, that is attack, this is the dependent variables, okay. and the final goal is to make a machine learning model, and then if new traffic will come, then we can detect that whether it's attack or not. That was the concept that we have understand. And this is the classification kind of problem because two yes no is there. Okay, these things explain, and we have write down everything here. Everything we have explained, that what is y, what is x1 x2 and small x1 x2, everything is clear to you. Okay, now how we can represent that concept that I discussed with you. Okay, now for that, each students may go for their own, okay, so that they can make the difference from others. Okay, do not try to copy the same figure or same representation. Okay, try to represent by your own after understand the everything. But first understand, then you represent. See, this is the representation, but do not try to use all of you same thing. Okay, you may think, you may change, or if you do for particular data set, of course the name may change. Okay, but try to understand in the small data set that what is going on. Okay, here you can see that we selected the service. Okay, service one. Let me explain a little bit more so that you can understand very easily. Okay. Oh, are you able to see this? No. Wait, if you not able to see, then you have to see. Okay, I shared it. Okay. Okay. I think you are able to see this PPT. Am I right?
Yes, sir.
Okay, good. That's very important concept. Those who are attending yet, please understand. You can, where is the insert? Yeah, yes. Okay. See, what happened? Up to this, you can see you have exact all cell fill. It means your data set is filled by everywhere. Means no missing one. Okay. But if you go below, then you can see that okay, this is these missing values are there up to j minus 1. Okay, these values are missing. Okay, then how we can fill it? Here you can see easily that these are the missing. It means you have to make a model to predict it. How you can make a model? You have to take this much of data set, okay, and make this service as a target, okay, service as a target, and build a model mi. Suppose this is mi, and then you use the model to fill this value. As I discussed here, that what is here, new traffic will come and the value is predicted by your model. Same thing, the value is there and model will predict the value and you fill this value. Okay, now your data is filled up to this. After that, if you go, then you can check that, okay, these two values are not there. Okay, we know how to fill this, but we don't know how to fill this. Then what we can do? We can make another model. Okay, that we discuss. Yet we discuss throughout the day that how you can make a model. Okay, select a good model, make a good model for predict HTTP in this case, because now we are going to predict this HTTP. Okay, using all are independent. In this case, what happened? HTTP is dependent and other source, destination, proto, service, level, these are the independent. Okay, and using that you make another model that is MJ and fill it. After filling it, you select another missing column. Okay, now you can go here. You know how to fill it because MJ is there. You can use MJ. Don't use MJ2. And here MI you may use. Here how you can fill it? Again you have to make different model for proto. Okay, and after making model you can fill it. Okay, similarly you go for this, and at the end, since it has no that's why no model is required. In this way you can fill your missing value. Okay, after filling missing values you perform the same operation that we did. Okay, and check what is the accuracy of that. Okay, and then this is the concept that you may use. Okay, and try to implement and report me if you have any kind of error. And the last one is how to find a subset of a level. See, what you saw in your data set or what you are going to collect data from different kind of experiments. Suppose you want to perform injection attack, okay, or suppose you want to perform ransom attack or DDoS attack, okay, and you collect the data. Then what happens? Suppose injection attack, you have some rows that actually attack, and related to that traffic that is not attacked. It means this is not attack which is related to your injection attack. If you perform ransomware attack from your tools that you are learning, okay, or in the data set that you have data, in that category you can find the different categories are there, okay. The major idea is that you are going to use ransomware, but the other that is not attack traffic, this is not related to ransomware. Suppose 50,000 data, 50,000 row you have, that is not attack, zero level, okay. And after that you have different kind of attacks. But can you say, see, this is very important idea. Can you say that the ransomware that you are talking about in your data set, from which among 50, 100, the 50, 100 that is not attacked, which one rows are there that you collected from your tools? Because what you did, you collect your data from different tools. Suppose ransomware attack, injection attack, DDoS attack, okay, and accordingly they have not attacked traffic also, okay, and you merge all data set and say that this is your data set. But if you merge and then I say that, okay, again can you say that which data is related to the table 1, the not attack data, okay, table 1, it means injection attack, which not attack data is related to ransomware attack, which not attack data is related to suppose DDoS attack, okay, then you cannot say, because you already merge, you already suffer, okay. Here the concept is there, okay. How to find the related subset of the level, okay. In the another case you can understand, suppose you have medical report, okay, in the hospital you have a lots of patients, am I right, and different departments are there. Suppose heart attack department is there, okay, heart attack patients are there, kidney patients are there, skin disease patients are there, okay. If you try to diagnose them, then you have to give different laboratory tests for different kind of patients, am I right? But at the end, if you want to try to merge all data, then what happened? The not infected patients is the zero, you level at zero, not infected. But infected, you have mentioned that, okay, this is heart disease, skin disease, kidney disease, okay. But the heart disease non-infected data is also there. Kidney disease non-infected data is also there. Okay, skin disease infected, not infected, also there. They mix all categories that is non-infected from different 3 disease. They already mixed and you cannot find. Okay, how you can find it? This is a kind of problem you may mention in your technical document that you are going to sort out. First method is, since we do not do not want to use our extra brain, then what we can do? We can select randomly. Okay, suppose you have ransomware in your data set 20,000. Okay, now you use 20,000 non-attack because both should be balanced, attack and non-attack. Now you have altogether 40,000, and then you perform the machine learning algorithm that we learn. But if you want to use extra brain, extra skill, then what you can say that taking the ransomware, okay, and then you have to find the closely network traffic related to ransomware attack. If you gather that information, that your model will be very excellent. Why very excellent? Because you are training your model very closely fighting data set, that is ransomware and not ransomware, okay. And I hope if you do this thing, it's very latest, or I don't know anyone experimented this or not, okay. But if anyone able to do, please inform me, okay, that you are able to collect that closest sample, non-attack sample related to ransomware or any attack, related to injection attack, related to this. It means you have to find out in the mixture of the non-attack data, what is the related of that attack, attacked code traffic, okay. And for that, since we are going to find out from non-attack and non-attack, if you, because within non-attack you are going to find out the closest attack traffic, okay. It means you remove that label. If you remove the label, then what happen? Your data set will be unsupervised. And if it's unsupervised, then you have to use which kind of algorithm? Unsupervised learning algorithm. Okay. Then to solve this problem, you may go for unsupervised learning. Okay. Or we may use some LLM or transformer kind of thing. We will discuss in next class. Then I will take your class. Okay. But here you try little bit your skill to solve these two ideas. Idea one, that is the handling missing value, and idea two, how to find a subset from the non-attack, mixture of non-attack, so that if you train your model, then it will be very competitor to each other, attack, non-attack. I think this model will be very perfect. Please give me this data. If anyone do this, okay, what kind of accuracy is there? If any improved accuracy will be there, you may compare it. How you can compare? Go for method one. Take a random value from 50,000. Okay. And then second, you apply this any unsupervised learning algorithm or any technique to find out the closest related ransomware kind of column from 50,000 non-attack column, and then compare these both results and check which one is good. Okay. Now these are the works that you have to do, and I hope if you start, then a lots of things is there to fill. Okay, write these things and update your overlay file. Okay, thank you all. If you have any question, please ask.
So please share the collab link. So
I will share everything, but if you have any problem, any doubt, then ask.
yes, sir.
Sir,
Okay.
one doubt. First I have said that I have made the model according to the train test, and also I have generated the IP address, and thereby I have gained the CSV file, and I have trained this. Can I compare these two in a separate
Yes, of course.
using the
but
neural networks?
Listen. The size must be same, because this time your train test that you downloaded, it has 2 lakhs of rows. Am I right?
Yes, sir.
And your data set, it may be 10,000. I hope.
Yes, sir. Yes, sir.
Then how can you compare? Understand? Either you collect 10,000 from 2 lakhs and then train and then test which data is more perfect. Okay.
Okay, sir.
Getting my point or not?
Yes, sir. Yes, sir.
Same. If you compare, then both must be same kind of candidate. Okay. Do not
Yes,
go.
sir. By using the neural networks, can I train both the models and get the accuracy?
Any network you can do. Don't worry about it. And you can find the code very easily on the internet.
Yes, sir.
Okay.
Yes.
But since you learn these things, then try once. Okay. Please try these things so that you can, if you suppose in future, if you want to use some random forest or XGBoost, that time you must have sufficient code in under your hand so that you can copy paste and perform the operation. Okay.
Okay, sir.
It will give you some
One doubt,
confidence.
sir. In the
Yes.
overlay file, can I add all these things that is fetching my IP from the Kali Linux and all these white stack?
Even how you install, or if you face any kind of error while installing, challenge during your experiment, you may write. These things is good for you. Okay.
And also attach the screenshot. How can I use this?
You can add. Screenshot, you know how to import figure. I already taught.
Yes, sir. Yes.
Okay, it's very good. Now it's your responsibility how to make attractive. Because my thing that Since these are the common things, so do not think that you learn something very sacred thing. No, everyone knows. Okay, only how to represent you, how to represent your idea. Are you able to code this or not? Okay, you have to solve. And if you go for in future, if you go for any kind of interview, you may write these links in your CV that if you want to know my technical skill, you may look on Overleaf, Colab, or Hugging Face, GitHub. These are the positive thing for you. Therefore I told to everyone, do by yourself. Do not copy paste. Otherwise, it's very difficult to share that document with your interviewer because same document will be there. Yes, another doubt? Everyone worry about attendance. Is there anyone please sir, can you have the attendance? Okay, okay. If you have any doubt, any question, because you have 2-3 days left. After that we will meet. I think 4-5 days. Okay, and you are going to learn how to use the tool. Use that tool, generate the data, and you know how to use the data now. Okay, everyone, I explained the things. Video will be shared. Okay, use the publicly available data set, and same thing use on your data set and compare and show. Lots of things you have to do. Okay, now no problem, no.
Sir,
Okay.
we can stop here.
Yes, any student, any doubt, then tell me, otherwise we will stop. Okay, no doubt, sir. They only want video and collab.
Sir.
Link. Okay. Yes, tell me.
Sir, I'm actually having problems doing the codes, the Python codes, because
Huh.
I'm not too experienced in it. So can you suggest any playlist or something so that I can learn how to use the actual comments?
Use the codes are there now. Use Colab, the my shared Colab. Start to do, because the basic code I already provided. This is the thing that you need to know for performing data science operation. And while filtering data, extracting data, I also give a little bit code there. Okay.
Yes, sir.
First go my 3-4 Colab one by one. Okay. And then you start what you want to do, what you want to implement. First thing in your brain. Okay. If you want to learn the basic, it will take 6 months, 1 year. Understand? Do not learn only. Try to use, then it will reduce. If you start to implement the thing, you may learn all things within 1 month. Okay. Now you should not think that you are a beginner. Okay. You have already a lots of course that I gave you. Try to run on your Colab. I show you today also that how you can run. One by one run, understand. Okay. And then find out one good problem and try to solve it. Suppose one problem is to generate data from the cybersecurity tools that you are learning, how to import in CSV file. I think something raw data is there. It's tricky to catch the data, and then some cleaning process will be there. Then you search. Suppose you want to convert some. Suppose the data is there, some IP address, and now you want to, or you may find to collect some protocol name, but in the result in the log file you may find TCP_3. Suppose _4. Now you want to cut _4. Then you write that I want to trim, or I want to strip from a text. What is the code in Python? They will give you, and then go for the detail of that function and learn. Slowly you can learn. Okay. Understand?
Yes,
Start to work, then you can learn.
yes. Thank you, sir.
Now next. Okay, you can refer to our CS Python course. It's available. It's okay. In YouTube, you can find a lots of Python coding. But I told you, if you start to work, you will learn faster. Otherwise, you will learn and you may forget the things. Okay, you can find a lots of things. Okay, find out your error while doing the code, and that error you go for in depth. Okay.
Yes, sir.
Okay, other problem?
Sir, in the overlay file, I have sent you, I have made my own AI assistant and it can perform the various tasks. And I uploaded in the overlay file and also shared with you, and you have provided me the rank 0, I guess. Sir, can you check me and inform me how can I improve that model or?
Okay, okay, I will write. Listen, if you, everyone, if you share that link, that I will write in the abstract that what is going on, what you need to do. Okay, you read the abstract, you read the instruction, accordingly you improve the file. Okay. If you share, then parallelly you improve. Do not stop. Okay, you have to modify your file continuously. Okay.
Yes, sir. Yes.
Okay, I will check again and I will write in the abstract. And all of you, please